So what's classification in the context of machine learning? So by definition, classification is just a supervised learning technique for determining which class the dependent variable belongs to based on one or more independent variables. So alternatively, we can call these features, okay? And in Worker, we call these attributes, okay? So supervised learning here simply just means the algorithm or classifier learns from labeled data sets. So that means in our data set, both the independent variables and dependent variables actually have labels where we can train our classifier, probably, for example, logistic regression. So in addition, we have two broad main types of classification. The first one is binary classification, where our task is to predict one of two classes, right? So for example, in a COVID test, you can either test positive or negative, okay? And remember, with classification, it's qualitative in nature, the categorical outcome, right? The dependent variable is categorical in nature, meaning that it's just made up of a nominal data type, qualitative in nature. The second type of classification is multi-class classification, where the task here is to predict one of more than two classes. It could be you have 3 classes, 4 classes, 5 classes. We call that a multi-class classification problem, where you want to predict one of more than 2 classes, okay? Also, we could, the broad categories of supervised learning, we have classification, that's what we're looking at, and the other is regression. So one of the differences between these two is that this one, the dependent variable is qualitative in nature, and here the dependent variable is quantitative in nature, meaning that, for example, we want to predict the price of a house, right? So the value there of our Y is numeric in nature. And the value of our Y here is qualitative or nominal or categorical in nature, okay? The next thing here is to help us illustrate how classification works. So suppose we have data points projected on a scatter plot. So our classifier will try to draw a decision boundary, right? This decision boundary will help us to classify whether a data point belongs into one of these 2 classes for binary classification. A good example here, suppose you wanted to train your model to predict whether a product review is positive or negative, right? So it will draw a decision boundary so that now if you have a future data point or a new data point, depending on where it lies, you can see now this is a new data point. So we can now actually say, based on this classification, this definitely will be a negative review because it falls on the side of the classification boundary or decision boundary. Okay, so with classification, these are the 5 top algorithms that we need to know, or rather you encounter in your career. So we have logistic regression, decision trees, naive Bayes, SVM, and k-nearest neighbor. Okay, so in our next video, we'll look at how we can implement this or run this in Worker.